Hi everyone, welcome to this lesson on angle properties. Most of this lesson is review of grade 9 material, but I thought I'd go over it again just in case you maybe have forgotten a few things from your grade 9 course. Okay, so these are some angle theorems that we're going to be using to solve some problems. Most of these you may already know, but just in case it's a review. So the first one is the complementary angle theorem, which basically says if you have two angles B and A, and together this is a right angle, then B plus A equals 90 degrees. So that's what it means for two angles to be complementary. They add together to give you 90 degrees. The supplementary angle theorem, same kind of idea, except in this case we have angles A and C, and since they together they make a straight line, they have to equal 180 degrees. The isosceles triangle theorem, since this is an isosceles triangle with these two sides the same, A has to equal B. So the two angles that are opposite the two equal sides have to be the same. Equal sides, equal angles. Excuse me. And then the SAT, the sum of the angles in a triangle theorem, is simply that if we add all the angles up in a triangle, we get 180 degrees. Okay, just like for a triangle, there is an interior sum of a quadrilateral theorem, and that simply says that all the angles in a quadrilateral equal 360 degrees. I'm not really going to do anything with that. And also, for any polygon, whether it's a triangle or a quadrilateral or a pentagon or anything like that, the sum of the exterior angles is 360 degrees. So note here what the exterior angles are. They're the angles on the outside of the polygon. Okay, we have some other theorems. So the first one is EAT, the exterior angle theorem, which basically says these two angles here are equal to this angle here. And this angle here is basically an extension of the supplementary angle theorem and the sum of the angles in a triangle theorem. But anyway, that's how that one has to go. The opposite angle theorem. If you have two straight lines, then angle A has to equal angle B, and again, this is a consequence of the supplementary angle theorem. So in this case, A equals B and B equals A. Okay, and then we have three patterns that all are part of the parallel line theorems. So basically you need to have, for this to work, you need to have two parallel lines like this, or like this, whatever. And then we have an intersecting line, and in this case we can draw a bunch of angles and they're related to each other. So in this case we have what's called the F pattern. There's my F, did you see that? F. So in this pattern A equals B. Then we have the Z pattern. So here is the Z pattern. It's kind of a backward Z in this case, but you know, backward Z, that's cool. And so in this case, once again, we have A equals B. And then we have the C pattern, which is this one right here. C pattern, this one right here. So in this case, A plus B equals 180 degrees. Okay, so let's use those theorems to actually work out a few things. So in this case, in this first case here, we have a triangle, and the base has been extended like this, and we're looking for this angle X. And in the second question, we have a quadrilateral here with three of the angles known and the third one unknown. So pause the video here for a moment and try and work these out. Okay, so in the first example, we have, we're going to be using the exterior angle theorem. Because the exterior angle theorem says that A and B, these two angles, equal to 128 degrees. So I can write that down by saying X plus 72 degrees equals 128 degrees. And then I'm just going to solve so that X equals 128 degrees minus 72 degrees. Just like that, so X equals 56 degrees. Okay? Straightforward enough. In the second case, I'm going to use the sum of the angles in a quadrilateral theorem. So, sum of the angles in a quadrilateral theorem. I don't think that's actually the acronym, but anyway. So we need to know that all of these angles together add up to 360 degrees. So we can write 3x plus 51 degrees plus 94 degrees plus 47 degrees equals 360 degrees. Okay? If I subtract all of the angles on the left side from 360 degrees, I get 168. So 3x equals 168 degrees. And then I divide that by 3, so I get x equals 56 degrees. Same thing as before. Okay? So there you go. There you have it. Two more examples. In each case, there are three angles which are unknown, x, y, and z. X, y, and z. I want you to think about what you know. In this case, note that there are some parallel lines, so you'll probably use the parallel line theorems. So, yeah, try and figure those out. State the angle theorem that you use. Okay, pause the video here. Okay, so looking at the first triangle, excuse me, the first shape over here. We've got a few options, but I think I'm going to start off with my parallel line theorem F pattern, which I see here. Okay, there's my F pattern there. Because that gives me the value of y. Y has to be this 160 degrees. Oops. Okay, y equals 60 degrees. So then, I can use the supplementary angle theorem, so that I can say that 50 plus z plus 60, because y is 60, equals 180 degrees. So that's the supplementary angle theorem. Okay, and then if I subtract from both sides, I get that z equals 70 degrees. Degrees. Okay, so I figured out y and I figured out z, and all that's left is x. And so for x, I'm probably going to use my z pattern to say that, so my parallel line theorem, z, x equals 50 degrees. Okay, just like that, x equals 50 degrees. Okay, so that's basically that one. Looking at the second shape, I can see that I start with, well, again, I have a few options here. Okay, so once again, I can start with my supplementary angle theorem. So supplementary angle theorem, 76 plus x plus 50 equals 180 degrees. Okay, and then subtracting x equals 54 degrees. All right, and then I see that I have a C pattern here, So I can say that my parallel line theorem C pattern gives me that x plus z equals 180 degrees. So therefore z, since I know x equals 54. Z equals 180 degrees minus 54 degrees, which is 126 degrees. Okay, and I can use the C pattern again here to show that Z plus Y have to equal 180 degrees. So Y has to be the same thing as X, in other words, which is another theorem, a different theorem related to parallelograms, which I'm not going to get into today. But just to summarize then, Z plus Y equals 180 degrees. That's again from the C pattern. So Y equals 180 degrees minus 126 degrees equals 54 degrees. Okay, so that's it. We've used a bunch of different theorems to work out a bunch of different angles in different situations. See you in class.